And thanks to everybody who's catching us on the live stream. I'm really excited about the speakers we have for you tonight. And the way I try and explain internally what we want these speaker series to be is imagine you're at a security conference and you've been there for 3 days and you've seen a lot of talks. And you're about to leave and someone's asking you like, oh, what did you see? What was good? And you can pull out like maybe one talk or two talks that really stood out. That's the experience we want from you here, except you skip the 3 days, you jump right to those two talks. And you don't have to fly anywhere because it's right here in your backyard. So I think we've got a couple of those talks for you today. So Teddy Reed is here, and he's going to speak to you about defending, detecting, and responding to hardware and firmware attacks. Teddy Reed is a security engineer at Facebook, developing production security tools. He says he's very passionate about trustworthy, safe, and secure code development. He loves open source and collaborative engineering when scale, resiliency, and performance enable defensive and protective software design. He also loves long walks on the beach and making friends. Please welcome Teddy Reed.
I have a bit of time. I want to save a lot of that for questions and hopefully answers. Let's just jump into it. How many people are using, or how many people here are defending a network, like an enterprise? What are the rest of you doing? Attacking an enterprise? Nice, okay. So, what's up, trolling? Perfect. Sitting on a couch, watching some fool in front of you. All right, so how many people who are defending are worried about firmware and hardware attacks? And you like ruined my, build up. No one does that. All right, so why am I wasting your time talking about it? Is that a different mic I can use? Yeah. Cool. Thanks. Okay. So, at Facebook and probably like everyone else out here, if you have bare metal or if you have a client fleet you have to defend, you probably should be worried about firmware attacks. At least now is the time, like any, to get ahead of it and start collecting a lot of data such that later you can detect and defend against firmware attacks. So in a couple other presentations I give here, I kind of go through and list all of the attacks, but I think everyone here is very savvy. We can go on the internet and look for popular talks, find all the latest and greatest proof of concepts, firmware attacks. Where do they happen? Like when I say firmware attacks, what's popping into your minds? Thunderstrike, yep. So Thunderstrike, origin of the compromise is there's Thunderbolt exposed on these laptops here. That's connected to the PCI bridge. I can do a lot of things when I connect to that PCI bridge because in order to support devices that are attached, I have to allow it to run code as soon as it connects. I run that code in a super privileged mode. It bypasses a lot of authentication checks for persisting in ways that no one ever checks, no one ever audits. No one gives you the capability of auditing, right? That's scary. What else other than Thunderstrike? Qualcomm, okay, it's not going to really affect this. Why is that a big deal? Phones? You have phones on your enterprise? Oh my gosh. Yeah, absolutely, right? Okay. Right, and there's a lot of phones out there. There's a lot of Android phones out there. The fragmentation for Android updates includes fragmentation for Android firmware. If I asked you, can you enumerate all the firmware versions and the vendors on your enterprise right now, could you do it for me? It's difficult, right? Who knows if they're even telling the truth if you do have something that can, if you do have some sort of like, mobile iron that can go and tell you the firmware version. Who knows if it's true? What else? Juniper backdoor, a little out of scope, but yeah. Damn. What's up? The equation group. Oh, yeah, okay. So state-sponsored attackers who want to get access to your data. Who protects data that like a state, doesn't have to be the US state, but another state might want, right? A lot of us. If you have a data center somewhere and you're protecting user data, chances are someone out there with a lot of money wants access to that. I saw some other hands up. Okay, USB firmware attacks are very valuable. So when I came up here, I transferred my presentation onto a USB to plug into this laptop. And like everyone was like, whoa, you're giving a talk about firmware attacks and you won't transfer over USB? That's the right attitude to have. I love that attitude. But if I want to attack this laptop here so I can present, am I really going to blow a 0-day in the USB driver, right? Those are hard to find. Where have those existed and where have people capitalized on those? Maybe not capitalized, but like made use of. iOS? One more? No, yeah. Has anyone used a USB firmware attack vulnerability? I have. So I needed to root my PlayStation 3 right after they took away the alternate OS. That's exactly how you did it, right? It was an amazing attack. And like I clicked a couple of buttons, downloaded a few things, and threw it on there, and it worked. It was super reliable too. So the logo that I have up here too is osquery. So who is familiar with osquery? That's wonderful. Okay. Nice. So osquery is the way that Facebook detects firmware attacks. And it's the way that we try to defend against firmware attacks too. So remember what I just said there. We're defending against firmware attacks, right? Not just detecting. So ask me afterwards how we do that. I'm going to go through these since a lot of people are familiar with it. osquery is a kind of general purpose visibility tool that you install on hosts and servers. It's designed to plug into APIs. It's designed to never fork. There's only one fork call in the whole program, and that's so it can fork itself and then monitor itself in case it starts using too much CPU usage or too much CPU, too much memory. It'll kind of kill itself and respawn, right? It's like a watchdog. I got that from Gur. When I was looking at Gur and trying to build a lot of the awesome things from Gur, that was like one of my favorite things, the watchdog. So it's your operating system as SQL, right? And this is kind of like the weird part that we kind of try to shove a lot of operating system concepts into tabular data, but it really works out, right? So think of your favorite thing about your operating system and how you would want to collect it and how you're collecting it today and see if you could represent it in tabular form in one way or another. So right, here's the concept. Think about all the attributes here. And then now, once you've abstracted that, we can put constraints on it. And there's lots of primary and foreign keys in your operating system. That's what makes an operating system awesome. Like everything's relatable. What's really cool about osquery, and I could say that 1,000 times, right? Because I'm like a super champion of osquery, is when we put the concepts into SQL, we can represent them across all operating systems. So like if something calls something a TID, if someone calls it a PID, I mean, we can represent that as probably the wrong thing if you're a zealot for one operating system or another to you, but we can represent it uniformly across all the operating systems. Here's the things we support. Yeah, if you're not running one of those, come talk to me. We can help. Here's what it kind of looks like. On the shell, you run it. You drop into a SQLite prompt. All your favorite SQLite commands are there. Want to run a query, it's SQLite. Here's my host, listing all the listening ports. So that's one of the concepts we've abstracted in tabular view. You can see I've got a couple things binding to 000. And if you had IPv6, it would list this too. Here's another cool thing I can do. I can represent files. I can represent things that you want to do with files too, like I want to hash them. I want to look at the extended attributes for them. So because this is a firmware talk, let's jump right into how we can use osquery to look at firmware. So on your Mac, if you have a Mac, one person has a Mac open, it's my buddy, he has osquery installed. Go ahead and run this. Select star from file where path is your bootloader. What's awesome here too is if I replace that equal sign here with a like, and then I put a %, why %? Why not star? Why %? I have no idea. But if I put a % here or a star, it will then list everything that ends in .efi. Yeah, you can do that across your entire file system too. It'll take a long time, but like, yeah. So there are lots of places on Apple devices where you can stick bootloaders. There are lots of things that let you override where your bootloader comes from too. How do I override what bootloader I use? I know there's some people in here that work for Apple. How do I override my bootloader in OS 10? NVRAM, yes. So you have osquery installed? Nick, can you select star from NVRAM? Yes. Exclamation point at the end. All right. Yeah. I don't know. I try to make jokes. If you guys laugh, that'll make me feel good. Yeah, right. It gets mad. All right, so kind of use your imagination how we can keep going with this. If I want to hash those things, here we go. If I want to join some things, your kernel too. So I've taken a couple concepts in the operating system and represented them as like this underscore info. Kernel info is one. If you pull up that web page I had on the previous slide, you can see system info is also one, as well as platform info. Platform info is probably the most relevant here because platform info will look and try to parse a lot of SMBIOS tables for you. System info does the same thing through proc. So now we kind of build up, and we also have an SMBIOS tables too, as well as the ACPI tables. So you can get kind of the same information from the operating system in different ways. And then we can use that to ask the operating system if any of those ways have been compromised or are now trying to lie to you. So essentially, we want to, and this is like the general theme, I'm going to give it away early. We want to see if an attacker has compromised our operating system and persisted somewhere firmware related, if they've covered their tracks in every single way. Right? That's the challenge I want to issue to all of our attackers. And it's kind of the same challenge that we issue when we do regular threat intelligence and incident response. Right? I don't need like you to be perfect. I just want you to mess up in one place. Right? So, and I also don't need to protect 100% of the ways. And like, who in the room thinks I'm like a total idiot? And like, there's no way to defend against firmware unless you have some sort of verified or authenticated boot, right? Because that's a valid thought. And it's right, I am an idiot. But, there's no way I'm going to convince all our operating system designers or our hardware vendors or our mobile phone providers to give me a verified, authenticated boot on all the devices that I support. That's a lost battle, right? We should keep fighting it, but we're forever going to lose. Instead, I want to focus on the information. I want to collect as much information as possible about these machines and challenge the attacker. Also, when I go to DEF CON and Black Hat this year and I see more ways to compromise a system, I hope that we already are gathering data about that and can see historically what normal looks like. That make sense? Okay, let's skip a couple of these. This is how you join. This is how I find out that Dropbox and Better Touch Tool are both running on my machine. Better Touch Tool allows me to push my windows everywhere, and it's also binding on 00. I usually say like, hey, this is my laptop right here. If you can find the IP, you can then start sending garbage to that port, and you can make all my windows go away, and you can crash this presentation. But it's not my laptop this time. Yes. Okay. Yeah, more me trying to sell osquery, really easy to config, and really easy to grab logs from Stickman Splunk. Another thing I like to say, and I put it in my little intro, is I love trusted computing, and I try as hard as possible to shove trusted computing concepts into osquery and the way that we pull data out. So the other thing that I would challenge you is like how, when we're pulling this data out, can we verify and authenticate that it did come from the machine I'm logging from? It's a really cool idea. And like, I just want to throw this in there. Things like Intel SGX really get me excited because it may provide us a way to authenticate the data we're logging from a machine someday, right? So it's kind of what I want to work towards. Another thing I want to throw out there is this is kind of a couple notes from an attack at Black Hat. This was the memory sinkholing attack. All the things that were required, all the changes that were required in order to make that attack work, including MSR changes. If any attack requires you to mess with undocumented MSRs, if you're logging MSRs over over time, you're also doing that same thing, that theme that I mentioned in the beginning, challenging the attacker to clean up after themselves. Right, so not only are we asking them to exploit our box, but we're asking them to return it to normal or evade all of the ways that we're logging, right? That's the challenge I want to issue. Who in here attacks machines? All right, challenge issued, right? Clean up after yourselves. A lot of people do it really well. Keep go. Another thing I love to point out is UEFI. It's awesome in that it allows us to develop firmware very quickly. It allows anyone out there to start pulling up new devices, building them, manufacturing them, selling them. But it also creates that Android fragmentation ecosystem problem. So this is a snapshot from 2014 of how much firmware was out there, like in bytes. And this was from a project where we wanted to dedupe all of the vulnerabilities found and presented on in UEFI and try to expand them across all the platforms they may affect. So it's like someone at Black Hat or DEF CON or some of the other great conferences out there, those are the only two that I keep mentioning because they're coming up soon. But all right, someone at Zero Nights throws out an exploit in UEFI on a certain platform, we can instantly spin that into a number of other affected platforms, or at least check to see if they're affected. There's a lot. This number has grown to about 80 gigs of UEFI firmware updates for all the popular platforms. And when I say popular platforms, it's things like I see on a network, on a network that I defend. All right, let's jump into some data from Facebook. So we have about 12,000 desktop and laptops. This is from our corporate network. We're not allowed to throw numbers out there for our production network. So everything I say here, all numbers that I throw out there are going to be for our corporate network. So 12,000 desktops and laptops, most of which are Apple. Here are the least common kernel extensions running. Least common. Has anyone seen directhardware.kx? Have they seen it on their network? You should ask that person why it's there. I hope they have a good reason, right? So ask me a little bit more about direct hardware later, but essentially it gives you /dev/mem and kmem, the equivalent, allows you to read and write physical memory. It's like the first thing that you need for a lot of other attacks, or it facilitates a lot of other privilege escalations. So if you see this, it's probably part of the next step of the attack, which is the actual bad part, right? Or it's just someone, I don't know, reading memory. So a couple other things that I've seen that kind of, I pulled some out in red, things that scared me a lot. Insomnia X, someone trying to keep their laptop running all the time, never letting the CPU go into any other performance lower state. Viscosity is just another wrapper around OpenVPN. The Do-It. So I know Do-It from UEFI. What's Do-It in UEFI? Anyone UEFI developers? That scared me a lot. It's just an emulator for UEFI. PIA ton, just another OpenVPN wrapper. Why the KX was running out of temp? That's actually how the application runs. Like every single time it will write a KX into temp, it will sign it on demand, it will install that certificate into your keychain, and then it will load the kernel extension. It's wonderful software. That scared me. Yes. It's an attack. It's absolutely an attack, right? It's just people want it to happen to them. Here's a cool thing. So this is when Apple was upgrading from 10.10 to 10.11, and when we had pushed out the upgrade into our update, or into our monkey, and we were watching people as they upgraded. So over 1 week, these are the changes in kernel version as reported by osquery. This is cool for two reasons. One, if you monitor this when there's not a change, that's interesting. And this is sorted by hashes. So more hashes matching that reported dot makes this bar go up higher. So if you just monitor this regularly and you see a blip show up here and there, a different hash for a kernel, either someone's running their own kernel, there's an update about to release and they got the beta, or something else. if you monitor this when there's not dev. So file integrity monitoring. How much time I got? Cool. You put this on Etsy and you watch for changes to your configuration. That's cool. Why not put file integrity monitoring on /dev? How often do things change in /dev? What's the easiest way to make a comms between kernel land and user land? A little IO control character device, right? An ioctl in /dev to communicate with your kernel extension that's going to hide new files as you write them. Where did we see that kernel extension? That was the Hacking Team's kernel extension. Monitor for changes in /dev, and you will see kernel extensions as they load and come up with their ioctl. Attackers, if you're going to use an ioctl to comm, hide that, right? As well as all the places you're using to persist. This is when I saw at Facebook, hacks. Yes, I saw that and I freaked out. That's actually a hardware accelerator for Android emulation. Yeah. Yes. Whoever was like, oh, we'll abbreviate hacks. It's amazing. I'm like, yes, it is amazing. Oh, gosh. So many years of my life. The EFI, the little EFI query I showed you before, here's that across Facebook. Again, hash count pushes the bar forward. That one right there that has none, right? That's two. Who are they? Luckily for me, that's me, just my device. Just running I catted some things to the end so that I could watch it show up here. And then grub and stuff that's coming from machines that aren't Apple, none of them. These are great tools too. I love to use chipsec on new machines that come in. So when Facebook purchases or asks our vendors to build us a new server, we'll pull it in, and the first part of onboarding it into our couple of development life cycles is to run chipsec on it. Actually, every time we do a revision there, we go in and run chipsec. If you can get that to your hardware validators and say, hey, we want this as part of the onboarding process and the testing process, that's great. That's instantly going to tell you if any of the hardware is not satisfying all of the vulnerabilities that have been released thus far. Project's developed daily. It's awesome. All right. Yes. Can we introspect into firmware components from user land? That's the question. Right. And that's the kind of driver that I use. So, osquery is actively developed every single minute of every single day. If anyone has any questions or wants anything firmware related, drive firmware, video card firmware, any of that, right? Ask this question. I want to try to find an answer for you. Right, and then I want as much data possible so I can aggregate it and sort it across the entire infrastructure, as well as have an event stream of changes so I can see these things change over time, and I know an exact time when it changes. Right, so here's a weird one, ACPI. I still haven't figured out a way to determine compromise by ACPI, but I log all the changes in the additions to tables. Looking at the ACPI tables that you have on your machine, if you find any of these, let me know. I don't know what they are. But it's totally valid for vendors to just throw in their own ACPI names. SMBIOS tables too. Still haven't found a way to detect compromise, but here's the aggregate count and the long tail of SMBIOS tables based on hashes that I found. Anyone knows a way to look at SMBIOS tables and determine compromise? I'd love to see that. Devices, so devices that get attached. So Thunderstrike, right? If you're going to be attacked by Thunderstrike, there is a series of events that are going to happen, as well as devices that are going to pop up. Let's, I think I have one of these. I do have it in a couple of slides. Someone mentioned NVRAM too. NVRAM is awesome on Apple. When your laptop crashes, let's say an attacker messed up and kernel panicked, you will get a panic info inside NVRAM. You also get the panic log with a little bit of the stack trace somewhere on disk. Pulling the machines that have crashed and looking at that will tell you when you mess up. Deploy a change and you crash all the boxes, this guy right here, and you'll see that, right? Pulling that out and parsing it, if you can see one person with inside their, R3 register, they have a bunch of 41s or 40s. Yeah. Did you know you can do vulnerability analysis and exploit detection with osquery? Yeah. How about exploit development? No. Cool. As a way, like, here's how you override your EFI boot file too, if you want to change it to something else custom. Look for machines that have that in there, and also look for, actually parse the data and see where it's pointing to. Let's see, there it is, there it is. All of the data that I've shown here is data that I gather and write alerts for at Facebook. All of the queries that power that data is at this URL right here. If you were to go and install osquery, it would drop in a bunch of example packs, as we call them, the organized queries. One of them is hardware monitoring and includes all the queries that we use. I like to promise that, like, if there's ever a way that we detect exploitation through hardware and we come up with a query for it, I will put it in this and I will make it public. Oh, yeah, here's the Thunderstrike one. Looking at your PCI devices, as well as the event stream. So there's a couple tables that have underscore events. This is a time sequenced order of changes on the PCI. And this is me, like, trying to run Thunderstrike against myself, taking the steps. I don't actually have, like, a working payload or anything like that. And this is what happens when I run Thunderstrike against myself. So I can create a kind of model for this and watch when it happens to other people too. It's very noisy, so I don't have like a, here, use this packet will detect Thunderstrike. It's very noisy. It requires me to go in and look at like 100 things every morning. But I'm getting closer. Cool. And then here are all kind of the tables that we use right now in all the packs that were at that URL. SMC is great too. SMC is great for seeing when people, there used to be an SMC bypass, and then SMC is also cool if you want to see if people disable SIP on OS X, as well as if people disable SIP at runtime. So if there's an exploit that's disabling SIP, I can see that too in those queries. Cool. That's kind of all I have. One last shout out to VirusTotal. All these hashes and stuff are also parsed by VirusTotal. So if you take the EFI that you have, the kernels, and throw them into VirusTotal, you should be able to get positive or negative hits. If I find stuff that's bad EFI, I will tag it as bad in VirusTotal. I don't tag any active like exploits that I see in the wild. I haven't seen any of those. Wink, wink. But proof of concepts that we grab, or proof of concepts that you can build from GitHub and throw them in there and tag them as bad. Cool. That's what I have. Please shower me with your questions.
So you, hello? No, it's.
So you mentioned that you guys also use osquery to defend, not just detect.
Ha
You use osquery to defend.
ha ha ha. Good question. It's in that those last couple of slides. It's actually. Oh sure. I mentioned before that we use osquery to defend as well as to detect. Right? How do we do that? So in the last couple of slides, why I moved into the last couple of slides is the event-based tables. So the event-based tables for Linux and for OS X. In OS X we use IOKit, in Linux we use UDEV. We monitor for changes to the device tree. In OS X we monitor for UDEV pools inside of Linux. And we try to write models around what is exploitation, as well as so a USB driver crash. That has a model inside of UDEV, because the UDEV, the last event for UDEV assigning the USB device to the most constrictive driver will not show up, right? That's how we use it to defend. So you see that, and you can take action almost immediately. For IOKit, it's the assigning drivers after a kernel extension was loaded. Or the same thing exists in IOKit as for UDEV. If you're going to crash something in IOKit, right, there are a few crashes in IOKit that get reported in the security announcements. Thanks, Ian. That's a very big target for attack and research right now. If they crash while IOKit's trying to parse, you will not see the most constrictive device pulled up. So the attack will happen, but you can pull that device off within minutes. Question in the front. How do we defend osquery from attacks? Yes, lovely question. So we at Facebook also run Carbon Black, and we have a couple other sensors. We have like a very general Splunk-based heartbeat too. So if you want to take down osquery, your challenge is to still mimic the data that osquery would throw out. And osquery puts data directly to our graph. It does not go through Splunk. And there's a couple configurations of osquery to allow anyone to do that. So you have osquery deploying directly to our graph collection. You have Carbon Black directly reporting to its sensor, and you have Splunk pointing to the large forwarders. So our challenge to an attacker is kind of like, if you want to hide from all of these, you must do them simultaneously.
Okay, and we have a mic for additional questions. So,
Thank you. How do you detect if OS query is still reporting? Do you because it seems to design for physical attacks partially, so I shut down your network connection, do my attacks, and then kill minus stop or whatever.
Man, there's good audience here. So for servers that are always connected, our heartbeat is 10 minutes. So if I don't see a heartbeat in 10 minutes, right, it's a problem. You think 10 minutes is too long? I do too. But absolutely, right. It's a good challenge. Emulate the heartbeat. For laptops, 10 minutes is very chaotic, especially if you're sleeping for the night or you're on your trip home and your connection is spotty, or you're connected to a VPN, you're tethering through a device while on travel to India, right? So we actually have to send heartbeats every 10 minutes. We have to buffer heartbeats every 10 minutes and send them as fast as possible. And then we have to take it back to like a day, or even in some cases 3 days, and make sure that all those heartbeats eventually arrive. So spoofing the heartbeats is just writing to osquery's cache that the heartbeat happened at that 10-minute interval. Absolutely. So the SGX that we mentioned in the beginning would be one really fun way to make it harder for people to, make it near impossible for people to forge, but make it easy, still hard for people to deny. Yep. Question in the back.
Thanks for the very interesting talk. One thing related to workloads. So when osquery was initially written, my understanding was that it was mainly written for client workloads. And you mentioned that you were streaming some of the data off in a very interactive and immediate way. Have you seen differences in what you can collect on client workloads versus server workloads?
So like what we can collect as far as like straining the bandwidth of the connection?
Not so much bandwidth as opposed to system performance.
System performance, sure. Yes and no. We consider someone complaining that it's popping up high in activity monitoring or on top as a failure. So the first thing osquery does is set I/O priority down to lowest possible for everything. For scheduling, for niceness, for file system walking, as well as we have pretty heavy constraints on RSS. So if you go over a limit, we kind of kill our worker and respawn and log that. If a query is responsible for that, then we will implement a backoff for how often we run that query and severely log that and escalate it to me. Yep. So the things that clients absolutely crash, when I say crash, I mean they fail to run their workload much more than servers. Absolutely. It's actually predictable too. I can graph the failures of all of the queries that I run, and it's pretty easy to estimate too if a query is going to run. It's pretty doable to set up a very simple test cluster to run your query against, as well as we do have in the client ways to profile your queries before you run them.
Have you tested these techniques with some of the non-open source commercially available hardware implants?
Oh, good question. No, I have not spent any money or acquired any exploits that aren't available publicly. But yeah, I would love to. Yeah, it's difficult, right? It's difficult it's difficult doing that. It's much more difficult publicly admitting that you did that too. Yeah, but I kind of like a dream is that that hardware monitoring pack of queries. There's another one in there called OSX attacks, and that lists very, very constrained like queries looking for very specific attacks, and they're named based on the attack. So that hardware monitoring attack is more just data collection of things that you can aggregate, sort, and then use some like kind of logic, some alert logic to escalate to you. I would love if that mimicked the OS 10 attacks table or the pack and had very specific things that absolutely indicated a hardware attack. Would love to, yep. Oh, sure. Actually, you've had your hand up a couple times and I haven't called on you. I apologize for that.
Hey, so I would assume if I were developing osquery, it isn't preventing osquery from running that I would worry about most. I would worry that somebody that was attacking my network would use osquery to figure out right places to attack. I assume, too, that you're smart enough to know that. Has the osquery query that is watching itself ever triggered at Facebook?
So, I mean, more plainly, have I seen anyone use osquery maliciously? No. And that includes against us. That also includes against us in a kind of synthetic red team. I haven't seen it done. I think it should be, though. I think next time we do run a red team exercise, we should consider that one of the MOs for attacking, and we should see kind of what it looks like. Yeah. Yep.
So you mentioned you don't really believe, I'm paraphrasing, but in having essentially the manufacturer sign their own firmware using OEM keys shipped with your box, which is what Intel is trying to patch with SRTM and TPM technology.
Right.
In the same time, we've seen, either I misunderstood or you essentially monitoring upgrades. And we've seen backdoors. You were mentioning the work from MITRE. So last time I saw them, like Xenokova and John Butterford did a malware which would survive an upgrade. Yep. To add to the complexity of that, we had both Dell and HP shipping in production servers which were pre-backdoored with firmware type of malware that was called Deity Bounce in the NSA Snowden leak. So how do they work together? Like, what is the baseline? In particular, like from my experience, it's extremely hard to find a uniform way to extract the firmware without trusting the firmware. So how do that fit together?
Right. So I would say it's very difficult to reliably extract the firmware. That is super hard. It's even harder. Right. It's even harder to trust that what you were given, if you did get it, is what is running on that machine. Yeah. Yes. Yep. And the firmware tracking is actually part of our chef, which is the way that we monitor or manage both our client fleet and our server fleet. So Chef is kind of our ground truth of what firmware, what kernel should be deployed. And then at runtime, when we use these checks, we can transact that against what should be our ground truth. So we collect it in two places. One, what we assume the machine should have, and two, what the machine tells us. There is no three, which is what the machine actually runs, without the assumptions that you have to trust the collection mechanism. Correct. Yep. Right. So a cool one is video card. A cool one that you can perform reliably, at least in all the checks that I've done, I've not crashed a machine. I have crashed machines trying to pull the platform, the UEFI platform code. I've not crashed machines trying to pull the video card UEFI. So video cards today usually implement a dual firmware. They have an option ROM at the beginning. They override a couple of the reserved bits in the option ROM to point to the offset where they throw their UEFI Dixie driver. And they stack them next to each other. So there is a very well-known place where option ROMs are supposed to be loaded for video cards in Linux. If you go seek there and then read about 65K of memory, you can correlate that against the very, very basic Radeon or NVIDIA drivers, which pull that out too. From the card. And that's going to be somewhere in your system firmware, virtual file system. There's a ROM node somewhere hanging off that PCI device. And you can actually just hash both of them and see if they're the same. Right. Very easy way. It's the same theme. Like, lie to me, please. But you better lie to me in every way I know how to ask you a question. Exactly. Yep. Please keep lying. How are we on time?
So we actually need to wrap up. I suggest anyone else who has questions for Teddy, you can mob him right now, actually, because we're going to take a 5-minute break so you guys can get another drink, or there's some sodas in the back, whatever you like, and we'll get started with the next one in about 5 minutes.
Thank you, everyone, so much.